I'm Clément. I come from Porrentruy, a really small town in Switzerland, where I live with my wife on a farm, on the family farm. And if you want to follow me for other content than cloud native content, I also regularly post blog articles on how I use cloud native technologies to do practical applications on the farm and how I collect the milking data and stuff like that. So some people like it. With that said, let's dive into today's topic, rapid and scheduled deletion of critical infrastructure workloads. How many of you came for the RUD acronym, or how many of you have already heard it? Only 1%, 2%, funny. So it's a euphemism called that they use, for example, it a lot SpaceX. When they blew their rockets up, they don't like to say that they miserably failed or did another try. They just rapidly unscheduled, just had a rapid unscheduled disassembly of the rocket. So that's a nice euphemism. I thought I would do the same for our problem where we had a rapid unscheduled deletion of critical infrastructure workload. It's a little less explosive and maybe a little more boring, but that's how IT typically is. So that led me to draw this nice awesomeness scale. So, well, rocket explosions are really, really highly awesome, explosive, and whatever adjective you want to use. Unlike IT incidents, which are typically boring due to typos or something that someone had done manually in the past, or, that nobody thought about, and etc. But IT incidents typically tend to affect a lot of people, so they are still interesting to talk about. So the agenda for today. First of all, I will introduce the Kubernetes infrastructure that we have at PostFinance. Then I will detail what I call infrastructure workload, which type of workload I'm meaning with that. Then I will explain how we use ArgoCD ApplicationSets to deploy our workloads, and infrastructure workload most typically. And finally, I will go into the incidents. So, Kubernetes at PostFinance, some figures. I'm not going to read all of those, but the most important one is that we have around 30 Kubernetes clusters and lots of namespaces, 1,400. 450 nodes, this is also important. And then the peak traffic, maybe it's important or interesting for you to know, around 4,000 requests per second on the ingress, and 400 card transactions per second on the peak times. So if we blew up one of the card payments cluster, then in 1 second, 400 persons are having issues with the ATM or are trying to pay at the shop and cannot do it. So it's quite critical. We cannot afford to have too much downtime. Some facts now: we are running open source Kubernetes, vanilla. We deploy it with a combination of Ansible and kubeadm. The oldest cluster will soon turn 5 years old. We always try to upgrade our clusters. We don't reinstall them or we don't do migration. We try to keep the clusters. We have a nice open source, or not open source, we have a nice in-house controller that a colleague wrote to manage all the namespaces for all our internal customers, which means that we don't have to do any manual work if someone wants an application. He just has to create a merge request, it gets automatically merged normally, and then he gets his namespace. Most of all deployments are deployed with ArgoCD. And finally, we are running Chaos Monkey on all clusters, including production, which means that all deployments need to be able to cope with pod restart. This helps us a lot because then it makes it sure for us that we can do the upgrades during the day, as application needs to be able to withstand a node drain, for example. And as I said before, the most critical workload is the card payment service. So with that said, let's have a look at our infrastructure workloads. So we operate our Kubernetes clusters ourselves. So we have to run a series of workloads, like, for example, metric collection. This is what I call infrastructure workload. Log collection as well. And out of those infrastructure workloads, some are more critical than others. Like K6, we could afford to lose the K6 workload. But the logging workload, if we lose it, or the metrics, we are basically blind. The ops team do not know if we have any incoming transaction or not, and they will soon start to call us. So, yeah, those are the most critical infrastructure workloads. And if we have a look at the kube metrics workload, what is it made of? So it's a series of manifests or resources. It's a namespace, and in there we have several deployments and daemon sets. So we have the kube state metrics deployment metrics server. Then we have a node exporter daemon set, and we also have an API service, but I will get to that later. So that's what we call infrastructure workloads. And how do you deploy infrastructure workloads on your Kubernetes clusters when you have 30 clusters and around 30 infrastructure workloads? Up until September 2022, we were using a combination of Ansible, Helm, and GitLab pipelines to do that. While it worked, it was a little slow, and if we had to rush a change or a fix to production, it would take hours because we have to go through all stages. Then we learned about ArgoCD ApplicationSets, which is something that maybe not all of you know about. How many of you have already worked with application sets? Okay, yeah. So it is known. For those of you who haven't, I will quickly explain what it is. So first of all, let's start by explaining what an ArgoCD application is. For that, I use kubectl explain command, and basically an application. The most important field for when you define an application is the source. So an application source is where you want ArgoCD to look for the manifest for your application that you want to deploy. And then the destination, which is the target Kubernetes server. For those of you who are more familiar with Flux, I tend to think of an ArgoCD application as a Flux customization. Then an application set. Basically, there's an important field in the application set. It's the template, and in the template field of the application set, you will put the application, an application spec. It's a little abstract. I will go over an example, but first a little drawing to help you get the concept. So an application set is there to generate a set of applications. It will render a template. So we have the template over here. And then it will substitute the fields that you want to template for each cluster. So here you have lab A, lab B gets translated to lab B, test A to test A, etc. So with one application set, you will have, if you have 30 clusters, you could have up to 30 applications without having anything more to do. For us, it's super important to do it that way. This means that when we add a new clusters, we don't have anything to do. It's automatically going to pick up all the needed infrastructure workloads. So that's how our application set look like. For example, this one is for the metrics server application workload. And so, as I said before, we have this template part where we have here an application spec with templatable fields. So we specify the source, the destination. Typically, the destination is going to be templated. And then you have a generator section, which is a little harder to understand maybe, but what it does is it's going to generate a list of clusters, and then it will use this list of clusters to template the application spec. So, with that said, let's dive into the incident. So, November 8th, 2023, shortly before the end of the day, one of my colleagues has trouble with an application set. He doesn't get to redeploy, or it seems stuck. So he tries a force replace in ArgoCD, synchronize option, which is, well, you get 2 warnings when you do that. So it's not necessarily the best option that you could have. But I mean, the one mistake that he did, and he was unlucky as well, he picked so this is a field that you can pick out of sync, which will pick all the application sets that aren't synced at that moment. Unfortunately for him, there was a series of application sets that weren't synced on top of the one that he wanted to replace. So when he did that, he started to do a force replace of those namespaces or those workloads. And a force replace starts by a deletion. So all of those namespaces were started to be terminated by ArgoCD and the API server. So you could think that it shouldn't be an issue because, well, if they are managed by ArgoCD, it should delete the namespace, the workload, all the deployments and everything, and then it should go back and come back online after a few seconds. You could lose metrics for 1 or 2 minutes, which is not too good, but you should survive that. But, well, that's IT, and, well, the world in general doesn't go as we want it to do, and it didn't go well at all. So as soon as he started doing that, he was facing such dreadful status windows, and well, it wasn't progressing at all. We had something that was blocking the deletion of the applications. So the forceful replace couldn't happen. Then we started to look a little what was going on. So we started to see why cannot we delete the kubemetrics namespace, for example. So when you do a kubectl delete namespace kubemetrics, you get a message that says, okay, delete it, and then it hangs. And after 10 seconds, you have a timeout. So something is strange. So you get the status of the kubemetrics namespace, and then you read a strange error message. Unable to retrieve the complete list of server APIs, metrics, Kubernetes IO, stale. I don't know if anyone in the room already had the issue. I guess so, yeah. This is something that's a little tricky to understand at first and that you're not expecting. First of all, let's explain what an API service is, maybe. So it's something that we typically don't look at because Kubernetes takes care of that for us. And most API services are local. This means that they are directly handled by the API server itself. However, you can also have external API service, which is the case for the metrics Kubernetes IO API service. And by the way, this one is responsible for showing you the CPU and memory usage for your pod and nodes. And so these external or internal API service, they are then reachable through this endpoint, kubectl get. You can use the row flag to specify that you directly want to access the API endpoint. And so APIs, then it's going to be the name of the API service, and then the version, and then you can query the API service. So that's what an API service is. So why couldn't we delete a namespace, and how is it related to an API service? We had a circular dependency. So let's go over it. So we started a force replace sync. To do a force replace sync, you need to delete the kubemetrics workload. If you delete the kubemetrics workload, you initiate the deletion of the kubemetrics namespace. Because you do that, all the pods are gone. And because the metrics Kubernetes IO API service, if I go back one slide, because it's reachable through a service, you just made that service unavailable. So Kubernetes cannot reach that API service. And now why does it make the namespace deletion impossible? Well, when Kubernetes, if you go into the API server code, when Kubernetes wants to delete a namespace, it first needs to discover everything that is running in that namespace to clean it up. So it needs to call all API services. And if your API service is not reachable, then it's not going to be able to delete the kubemetrics namespace. And then you have a circular dependency that you cannot break. And you can never recreate the kubemetrics workload because you are never able to delete the namespace in the first place. And you might also have already encountered when you put a namespace to the terminating phase, there's no way to get it back to ready. You have to delete it first. So kubemetrics couldn't delete. All deleted namespaces are staying in the terminating phase. And kubecontour, kubelog, and all the other application sets that I showed before are also in this state because it impacts all the namespaces on the cluster, which means that we don't get any metrics and we don't get any logs. So at that time, it's a little tricky. And yeah, well, that's typical. So now, how do we break this circular dependency? Well, it's quite simple actually. You just have to delete it. You delete the API service from the Kubernetes cluster. Because we were in a rush, we had to do that for all clusters. So I don't know if you know the kubectl for each plugin. It was quite helpful in that case. For example, here I use a regex and I say, okay, do that on all production cluster, delete me this API service, and with that, all API server all clusters were fixed, and finally we broke the circular dependency and the kubemetrics namespace properly deleted and recreated. So that's what happened. Now some safeguards. First of all, we implemented that later on. We hadn't done it at that point in time. We have now a split ArgoCD instance configuration. Beforehand, we had a central ArgoCD with all our clusters registered in there. Now we have a non-prod and prod one. So if someone is to screw something up on non-prod, it will not impact the other clusters. And another really important field to set in your application set, at least for the critical workloads like contour or the ones that are time sensitive, you can set this sync policy config flag, preserve resources on deletion. When you set this to true, if you delete the application set, it will not delete the corresponding applications. So by doing that, if you had done that before the incident, well, we wouldn't have had an incident, and we wouldn't be here to talk about it. Some considerations: which other circular dependencies could there be? So kubemetrics is maybe a kind of famous one. While any other API service extension could be problematic. And also Kubernetes resources with a finalizer. Typically, if you delete the controller, which is supposed to handle that finalizer, well, the finalizer will never be called, and you will never be able to delete the resource. Validating webhook as well. If you have a validating webhook, let's say kubeopa gatekeeper, and you delete the pods for opa gatekeeper, but you still have the validating webhook, you're not going to be able to do anything. It would be even worse, actually. If you have it in a mode configured where it fails strict, then you really have a problem. So that's it for the considerations. Now, one statement. In our opinion, GitOps saved the day. Okay, for sure, we had the misconfiguration. We shouldn't have done this force replace sync, and we should have avoided this incident. But once we were able to break the circular dependencies, all the workloads were back in around 1 minute, which is, well, with Ansible, would have taken a little more than that. So for sure, it's super fast when you want to deploy something. If you want to deploy a bug on production, it's going to be super fast as well. You have to have the proper safeguards to prevent that. But if you did properly, ApplicationSets and GitOps helped us a lot to go over this incident. Now let's reproduce the incident, because that's the fun part. Well, I won't do it on live clusters because I don't want to end up on Tages Anzeiger or NZZ front page. So we have our kubemetrics namespace running locally on a kind cluster. We just have one pod metrics server. Is it big enough, by the way, to read, or should I maybe increase a little? Maybe it's better like that. Maybe I can also show you the API services that you can find on a Kubernetes cluster. So most of those are local. Local means that it's the API server itself that will take care of those requests. But the kubemetrics metrics server API service, this one is what I showed before. It goes to a service in the kubemetrics namespace on port 443. I can also maybe show you how it looks like when you call that service. APIs, metrics, where was it? I know, kubectl get row. So that would be metrics. So that's how you call the API service. And when you do that, the API server will forward a request to the actual service and to the metrics server pod. And here, well, there's not much of interest, but if you look at the nodes, well, you see what metrics server puts at disposition of the API server. So you see, for example, the CPU usage for the node and for the memory usage of that node. Okay, so I have shown you what an API service is, what it reaches out to. So now let's trigger the incident. So basically, when we did a force replace, ArgoCD wanted to delete the namespace. So let's delete the kubemetrics namespace and hopefully trigger the incident. So if I go in there, the API server is discovering every resources in the namespace. It's deleting those. And then the namespace stays in terminating phase. Maybe I can show it like that. As we see here, discovery failed for some groups, unable to retrieve the complete list of server APIs, metrics unavailable. If I try to query again this API service as I did before, I will get, okay, the server is unable to handle the request, service unavailable. So we have the snake biting its own tail again. And now let's simulate also the fact that those namespaces are trying to be deleted. And here it's going to be the same. After a few seconds, I get the error. So it's now time to fix the issue. So if I go back to my API services, I have the metrics server API service. It's unavailable. I delete the API service. And kubelog is already gone. Kubemetrics is going to go away after the exponential back of window is gone. So maybe in a few seconds it goes away. And then once it's gone, you can recreate it. So super simple when you know what's going on and how to fix it. A little less simple when it's 5 o'clock and you have an incident at hand. But we managed it. So yeah, that's it for the demo. And that's also the end of the talk. I hope you have some questions and you learned something today.
Nice, thank you very much. Any questions?
Yeah.
Hi. Did you consider using ArgoCD sync phase options, and why didn't you choose that?
Yeah, that's a good point. Actually, what I didn't mention to not introduce too much complexity was the fact that for the Kubemetrics workload, we do it a little differently because we have 3 different workloads living in there, and we actually have a 4th one just for the namespace. And so what actually happened is that there was a force replace of both the namespace workload, which is completely unaware of what lives inside the namespace, and the other workloads. If we had had everything in one application, in one workload, ArgoCD would have noticed that it would have started by cleaning up all resources, including the API service, and then it would have cleaned up the namespace. But because we have a split scenario where we had the namespace in one workload and the rest in other workloads, he didn't know about that, and otherwise we wouldn't have had the incident maybe. Not for that namespace. For the other, I didn't mention that, but the other namespaces or workloads that were deleted also introduced other circular dependencies with finalizers that we had to chase around. So that's a good point. There was another question in the back, or?
Yeah, maybe almost the same thing. Did you manage to implement some safeguards against the same issue happening again? Like maybe some ArgoCD permissions or something that you just
couldn't do a force replace, for example.
Mm-hmm.
We can still trigger a force replace now if we wanted to, but the critical application set have this config spec that I showed before, which means that if we delete it, the applications are not going to be deleted, so we wouldn't be impacted. And it happens sometimes that you need to do a force replace, but maybe we should look into that more to, at least now that we have the split setup, that maybe we should prevent on the production instance that we are able to do a force replace, because that's not too good. It's a good point. Yeah.
So have you considered if there are any ArgoCD hooks or finalizers that can be used so that Argo can delete the application properly?
Yeah, well, that's a little the same as before. Actually, it would have done so automatically if if we had all the workloads in one, all the manifests in one ArgoCD applications. But because we had like 4 different applications going into the same namespace, it didn't know about it. Now I don't know if you could have a synchronization hook from one application to the other one that they have dependencies. I'm not sure if you can model that in ArgoCD, but we haven't considered that at the moment.
Any more questions? Very good. Then a round of applause again. Thank you so much.